Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Faris Haziq bin Edwan. So I will talk about the introduction of the project. So the first introduction, the first point of the project is the purpose of our project is motor position controller is to take a signal representing the required angle and to drive a motor at that position. The second point is a microcontroller. This position consists an electronic component and microcontroller can provide AC control of a DC motor. So DC motor consists a starter, armature, rotor, and commutator with brushes. So the advantages why we choose the project can to develop constant torque over a wide speed application. So for this assignment, we try to simulate the plant of DC motor by applying Newton's second law with a D-D'Alembert principle by implementing P, PI, PD, and PID controller on the MATLAB software. So our purpose on this project is to compare which is the best controller work in the system.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Hazani binti Hazani. My metric number is CE190051. Today I want to present my part with each part methodology of the assignment. Okay, in this assignment, we assign to simulate the position control of the DC motor with the given step unit and also the input voltage. In this assignment, we need to build a block diagram. So we do some research and also the finding in the internet to design the block diagram in the MATLAB software to generate the output. We implement the P, PI, PD and also the PID as controller of the system. Okay, we also need to use a suitable software to get the desired output, and we try and error by using the MATLAB software and we easily get the result. Last but not least, we also ask the opinion from our previous senior that have already take this subject to gain more understand and also gain more ideas to run our assignment. Okay, lastly, we did watch some tutorial on YouTube on how to design the block diagram in the software. Okay, that's all from me from part methodology of the project. Thank you so much.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Aziz Shahmin bin Azman. My metric number CE190035. Okay, for my part, I will be explain about the simulation. Okay, first of all, this is our circuit. Okay, this is PID controller. Here we have step. For step, we have to set it to step time 1, initial value 0, final value 0.8, sample time is 0. Okay, and then we have 3 scope for VM, X1 and X. Okay, this is subsystem. Okay, this is a block diagram for subsystem. Okay, for run this subsystem, we have to create coding. Okay, this is our coding for subsystem. The data we get is from instruction given. We just only take it from the instruction and run, because if we didn't run this coding, our circuit cannot run. Okay, let we look for VM output after we run. Okay, after we run, we will look for output for VM. Okay, this is output for VM. this is output for VM, and then this is for X1. Okay, this is output for X1. Okay, and then this is for X. Okay, this is for X output for manual output. Okay, next we're going to look for auto tune for PID controller. Okay. Okay, firstly I will show for PID, and for another controller I will show for the next after I show this PID. Okay, this is tune response for PID. Okay, I will change this to 5 seconds. Alright, this is response time. After I change to 5 seconds. Okay, here I will show the parameter. Okay, this is parameter for tune PID. Okay. Alright, next is I change the PID controller to PD. Okay, now I want to run. Okay, after I run, let's look for VM output. This is VM output for manual, and then this is for X1 output for manual. Okay, and then this is for X output for manual. Okay, next we're going to look for auto tune for PD. Okay, let's retune. Okay, this is a graph after we tune for PD. Okay, I want to change this to 5, and we can look for the step response. Alright, this is tune response. After I change this to 5 seconds. Okay, let's look for parameter. Okay, this is parameter for PD, and this is tune, and this is for block. Okay. Alright, next is for pi. Okay, for pi, I have changed PID controller to pi. Okay, we run. Okay, let's look for output for VM. Okay, this is manual for VM for pi. Next for pi X1. Okay, this is for X1. This is for adds output for manual. Okay, this is for adds. Okay, next we going to look for tune for Pi, for auto tune. Okay, okay, this is after we tune for Pi auto tune. Okay, let's, when I change this to 5, alright, this is a response time after I change to 5 seconds. Okay, I will show the parameter. Alright, this is parameter for Pi auto tune. Okay, for the next I will show for P controller. I was just change this to P. Okay, let's we look for P manual output for VM. Okay, this is for VM. This is for X1. And then this is for X, for manual. And then we look for auto tune for P. Okay, this is auto tune for P. Okay, I want to change this to the response time to 5 seconds. Update the block. Alright, this is a step plot for tune response for P after I change to the response time to 5 seconds. Okay, this is the parameter for P. Okay, this is parameter for P. Okay, that's all from me. Thank you.
Assalamualaikum, I'm Nurhani Shazwani binti Mokhtar. My matric number CE190207. Today, I would like to present conclusion and recommendation. P, PI, PD and PID controllers was inserted into DC motor system to verify that one of the system create a linearized system. The response characteristic of the DC motor are improved through PID control. The optimal value of the controller parameters is obtained through the mathematical model of the DC motor, which include Newton's second law for motion, and the Allen-Bar principle is the equation motion of the DC motor. The PID controller, designed by changing the value of the control parameter, is more effective and easier way to adjust in order to improve the stability of the system time domain performance. Recommendation: use a PID controller in a closed loop system to obtain a better linearization system and easily adjust performance when creating objects. Reason: PID controller widely used to control 2 or more order layers, and the result is fast transient response and zero steady state error required by a closed loop system. That's all from us. Thank you.